Alrighty guys, we are going to add to our notebook yet again. So let's go to our table of contents. And next we are going to talk about equations just a little bit. So we're going to call this Introduction to Equations. We talked a little bit about the difference up here between expression equation. Let's dive more into what equations are and kind of the different parts and what we do with them and all the good stuff. So I'm going to do that on page, do I want this on page 8 and 9 or do I just want it on page 8? Can we get away with that? 8 and 9. We're going on 8 and 9. Let's do it. Okay. So let's turn our pages. And truthfully, in our notes packet that we picked up at textbook pickup, we have to go a little bit out of order here. I goofed up. So I think this is going to be the very last thing that you have. The next one I think looks like this. We don't want that. We don't want that. We don't want that. And then the very last one looks a little janky. We do want that. Okay. And we're going to flip that one over. I don't know if that's how yours came, but we want to be looking at this side here. And we're going to fold this in like French drawers. So, boop, boop, like that. And I realized as I was looking through this earlier that I got printed a little goofy, a little wrong. So, it's okay. We'll make it work. I'm going to cut out the top square here so that I can see that equation that's at the top. Oops, I ripped a little. Like so. And then, I mean, if you want to chop a little of the top off, like that just kind of looks ridiculous. I'm going to cut that off a little. Oop. And if you want to cut each little door, you can to make it super cute. There we go. Put that on page 9. A little glitter tape, and then we'll get started. Okay. So these are all kind of just like vocabulary words. We are going to do a little math with this, but a little, for the most part, is kind of just vocabulary stuff. So if I'm looking at this full thing right here, this whole 5x plus 4 equals 29 thing. Actually, scratch it. Let's back up one step. Let's say I'm looking at just this 5x plus 4 part. Just right there. 5x plus 4. That guy all on its own. That is what we call an expression. So underneath here, this is where we're going to see how things got a little goofy. These were supposed to print next to each other, not underneath each other. So what an expression is a math sentence without an equal sign So we can have things multiplied, added, subtracted, divided. We just can't have an equal sign. And then our example of it here is the 5x plus 4. That would be a really good expression. So we're just going to move that example word up. Actually, I want to jump a bit and let's talk about the 29. So the 29 on its own here, that is what we call a constant. So a constant is a number all on its own. So a constant is a number on its own. Frick. It's going solo. Likes that single life. Number on its own. So our example of that is 29. And actually there's another example of a constant number here, which is a little weird and confusing. But truly, if I ignore this, I could call 4 a constant as well, a number on its own. So 4 would also be a constant number on its own. Even though it's kind of linked with the 5x, if we just talk about the 4, it's a constant. Okay, so then I actually want to go back now and talk about the whole thing. So once I put the 2 together with our equal sign, so this whole thing now, specifically our equal sign, then we have an equation. So an equation is a list of numbers, add, subtraction, multiply, divide, whatever, but must have an equal sign. So must have an equal sign. So our example here is the full thing. 5x plus 4 equals 29 is an equation. Another example of that could be something like 2x minus 1 equals 17. That's another equation. So just has to have an equal sign. Okay, jumping around a little bit. Let's see. Get some more colors going on in here. This little guy right there is a variable. And I know the moment we got letters involved in math, everybody got real mad. But a variable really just represents a number that I don't know. So what it means, what is means? Oh my God, I need an editor. Seriously. A variable is just a number I don't know yet. You know, if I'm trying to maybe find the length of something or figure out how much of something I need, but I know like the total, but I don't know how much individual. There are lots of different situations that we could think of where I maybe don't know the number yet, but I know a lot of the other things about it. And so hopefully knowing all that other stuff about that will allow me to figure out the number that I don't know. So a lot of people freak out, but it just represents a number that I'm hopefully going to figure out later. It's a number I don't know yet. So it could be X, it could be Y, it could be any letter that you like. I usually like to use M for Miss Sarah, but R, T. Sometimes we use T for time. All those are good. Okay, just a number I don't know yet. Next are terms. So let's get actually this guy going on here. We got a lot going on. That's all right. This thing right here and this thing right here are each terms. And I know I called for a constant, but it can also be a term. And terms are just numbers, or they're number letters. So like this was a number letter. Or just a letter on its own, that are all added or subtracted up. So it has to be add or subtract. It's just a bunch of different things that are added or subtracted up. It could be a number, could be a number letter, could be a letter. For example, here we had that 5x is a term and 4 is a term. 29 would not be a term because it's not being added up with anything. So maybe looking at this other equation over here, so this is coming from that equation. Another example could be if I look at this equation, my terms are 2x and -1 because we always take the sign with it. Okay. 17 would not be a term because it's not being added up with anything or subtracted with anything. Alrighty, next we have coefficient. How can I mark this? We'll do an arrow. That'll work. Let's get this one here. A coefficient is a number on a letter. Coefficient. If it's in the way. So a coefficient is a number attached to, oh my goodness, a letter. So in our example up here, our coefficient is 5, and that's the only one because it's the only number attached to a letter. If I look at this example up here, I do have one coefficient as well, and it would be 2. If you ever have a letter without a number in front of it, your low-key coefficient is 1. Okay, last but not least, we got this open and true and false stuff. So this has less to do with like the pieces of an equation and has to do with the equation as a whole. And what it means to be open is that you have a variable. So there is more than one variable, or variable could be a number of things. Like I don't know yet. So a really good example of an equation that is open would be something like y equals 2x plus 7, because I have more than one variable. I don't know what they could be. So that is something that is open. Something that is true or false is an equation that either makes sense or doesn't make sense. So your variable, if there is one, has one answer only. And the other thing that could happen, so the variable has one answer. I want or. Each side equals, so therefore it's true. Or each side is different, therefore it's false. My face is in the way again. Boop. So this is where things get a little bit sketchy, the stuff at the bottom here. So we're going to try some examples on page 8 to sort of clarify some things. So we could have a true or false equation if the variable has one answer, and it's true when both sides are the same, and it's false if the sides are different on my equal sign. Okay, so let's jump over to page 8 and we're going to try a few different types of examples. The first type of example I want to try is this true, false, or is it open sort of thing. So true, false, or open. And we'll try 3 examples like that. So if I have the equation 24 plus 18 equals 20 plus 22, I'm not trying to move things around. We are going to look at one side of the equation. We're then going to look at the other side of the equation and decide, is this equation true, so same on both sides, false, different on both sides, or well, I know here because I can do this. 24 plus 18 is 42. And over here, 20 plus 22 is 42. And so both sides are the same, which means it's not open. Like I know what both sides are. And they're the same, so true would be my answer here. Okay. Another example could be something like 7 times 8 equals 54. So I always like to think of these ones as like, if there's no variable, it's more a question. Like on this last one, is 24 plus 18 the same as 20 plus 22? I don't know. I'm going to simplify to find out. And then they were, so true. Same thing here. This is really more of a question. Is 7 times 8 the same as 54. And sometimes I goof up my math, but I'm pretty sure that 7 times 8 is 56, which is not 54. So these two sides are not the same. So false. Last example for this one. If we had something like 2x minus 14 equals 54, well, I don't know. I don't know what that side is. I don't know what x is. I can't simplify this to figure out if it is 54. If x is something, it might be true. But if x is something else, it might be false. So, open. And guys, all that to say, like, it's really super simple. If there's a variable, it's open. If there's not a variable and just numbers, like, do the math, figure it out. Are the sides the same? Sometimes yes, sometimes no. Mine yes, true. I know, false. The other type of problem I want to try with you is it a solution? So on that last one, I know probably some of you are dying to just figure out what x is, and maybe you remember how, and that's great. We're going to get to that very soon. But for now, let's say somebody magically gave you the solution and you want to see if it does work in the equation or not. So an example of that might be, is 3 a solution to 8x plus 5 equals 28. Okay, so again, I'm not going to solve it. I don't need to. They already gave me a potential solution. I'm going to see if it is or not. And so to know, I take 3 and I put it in for x to see if it's going to work out. So in place of x, I put 3. And now it's a question. Is 8 times 3 plus 5 29? So I can simplify. 8 times 3, because I got to follow order of operations, is 24, plus 5 is 29. So yes, it is a solution. And if that right there was the question, you would say true. If that right there was the question, I would say open. Because, well, I don't want to get into all that. That's too much for right now. Another example of this might be something a little bit harder, involving my second favorite F word, is 2/3 a solution to 3/2 x plus 2 equals 4. So again, not solving anything yet. Solving, we don't know. They're telling me this might be the solution for x, like that might be what x is. So I'm going to plug it in and find out. We're going to see if this is 2/3, will this all equal out to 4? So we write down our equation exactly as it is, but in place of x, I'm going to put 2/3 plus 2. And now it's really a question. Does that equal 4? I don't know. About to find out. Going to simplify some stuff. So I have to do my multiplication first, and 3/2 times 2/3 is 6/6. Or if you want to cross cancel, that's really good too. And they all cancel out, which 6/6 and all canceling out means 1. And 1 plus 2, last time I checked, is not 4. So no, it is not a solution. Okay, good luck. Hopefully it's easy.